All right, so we start at 0, 0, then go pi over 2, 1, 0, 3 pi over 2, negative 1, 0. All right, and then we take y equals sine of 3x. We take the period and we say, well, it's 2 pi divided by b, which is 3. So 2 pi divided by 3 is 2 pi over 3. So it should end up at 2 pi over 3, okay, which happens to be right here, okay, 2/3 of pi. So if pi is 6, 2/3 of that is 4. So we start at 0, 0, and we're going to end here. Well, the normal sine curve, where does it cross the x-axis again? Halfway in between the start and the end, right? So it should be halfway in between. I go up, and then I go down. That's another way of doing it. Otherwise, you go, well, just divide by 3. Instead of being 3 over, I'm 1 over. Instead of being 6 over, I'm 2 over. Instead of being 9 over, I'm 3 over, and so on. But it should end up like that. Sine of 3x. We good? All right. 11. (11) is negative sine of 2x. So I'm going to go 4 to get to pi over 2 on this one. Because 4 is a multiple of 2. So that's what you can kind of think of. All right, so I'm going to graph y equals sine of x first. So it's 0, 1, 0, negative 1, 0. Then I'm going to graph y equals negative sine of x. So 0, negative 1, 0, 1, 0. Then from the negative sine of x curve, I'm going to graph negative sine of 2x. So the 2 says, well, if my period is 2 pi over 2, it should end in pi. So it's going to end there, start there, and so I go halfway in between is there. So it'll be there and there. Should look like that. We good? 13 is a cosine one. What is 13? Y equals cosine of 4x minus 2 plus 2. Okay, so since I see that plus 2, I know everything's going to go up by 2. So I'm going to start my graph down lower to make up room so I can make it go up 2. 1, 2, 3, negative 1, pi over 2, pi, 3 pi over 2, 2 pi. Why did I go 4 in 4 spaces to get to pi over 2? Why didn't I just go 3 or 6 or 12 or why did I say 4? Because my period is divisible by 4. And you want to use a number that's divisible by the period. Because 2 pi divided by 4 winds up to be pi over 2. So everything's going to end up in that little space there. All right. So I'm going to start out by graphing y equals cosine of x. We start at 1, go to 0, go to negative 1, go to 0, go to 1. Looks like that. And then I'm going to graph y equals 4 cosine y equals cosine of 4x. So it's 4 times skinnier. So instead of going over 4, I go over 1. Instead of going over 8, I go over 2. It's going to look like that. And then we're going to add 2 to it. So if I add 2 to it, I'm there. there, 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 and there. Okay? 15. What do we have for 15? I don't remember at all. Didn't we?
9, 11, 13, 17.
Oh, we skipped 15 and went to 17? Yeah. So what's 15, Dale? What? You didn't write it down? You just have graphs down? You're just that good? All right. What do we have, Parker? Okay. Which means, because this started out as y equals 2 minus sine of x over 4. Okay? So, whoops. So, what I would write this as is sine of 1/4 x. My b is 1/4. So if my period is 1/4, what's 2 pi divided by 1/4? Well, you multiply by the reciprocal, my period is going to be 8 pi. So I got to fit everything into 8 pi. So what I'm going to do is, as I go along here, 8 pi is going to be over here somewhere. So I'm going to have to make it pretty tight. So if I go pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2. That's still not even going to fit in there. So I'm just going to go pi, 2 pi, 3 pi, 4 pi, 4 pi, not 5, 5 pi, 6 pi, 7 pi, 8 pi. All right. Then 1, 2, 3, -1, -2. All right. So, first I'm going to graph y equals sine of x. So sine of x starts at 0, goes to 1, goes to 0, goes to -1, goes to 0. Then it's going to be negative sine of x. So I'm going to go y equals negative sine of x. So it's going to be 0, -1, 0, 1, 0. Okay. Then we're going to graph, let's go orange. Then we're going to graph y equals negative sine of 1/4 x. So I'm going to be 0, and then everything's 4 times further away. Okay? So instead of going over 1, I'm going to go over 4. Instead of going over 2, I'm going to go over 8. And then 12. And then 16. And then from there, I'm going to go up by 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. There I am. Okay, so that was 9 through 15. Then we skipped 17 and went to 19. 19. Y equals what on 19, Cameron? It looks something like that. Okay, I see the 2. And the 2 means I'm twice as skinny. And then the minus pi over 2 means I'm going to shift to the right. So I'm going to go pi over 2 is going to be 4 this time, just because. That's nice and divisible by 2. 4 spaces is divisible by 2. And then it stretches everything out a little bit so I can see things better. So we start with our normal sine curve, y equals sine of x, which goes 0, 1, 0, negative 1, 0. And then I go y equals sine of 2x, which makes everything twice as skinny. So it's going to end up in the length of pi. So instead of going over 4, I go over 2. Instead of going over 8, I go over 4. Instead of going over 12, I go over 3. And then I'm going to move everything to the right, pi over 2. So move everything 4 spaces. Whoops. That's 5 spaces. 4 spaces to the right. So it ends up like that. $21. This is the bugger that's a little different. On 21, we have y equals, is it the sine of pi over 2x minus 3 pi over 2? Did I write it? Plus 3 pi over 2. All right. So I'm going to go like that and like that. Because to do this one, I need to factor out the number that's in front of x. That needs to be on the outside of the parentheses. So all of a sudden, we get x plus 3. There's no pi's involved in that. So that should give me a tip-off that something really unusual is happening. So if I take 2 pi divided by pi over 2, that's the same as 2 pi times 2 over pi. My pi's cancel, and I get 4. So what's going to happen is my normal sine curve is going to be regular numbers. 1, 2, 3, 4. So I'm going to graph y equals sine of pi over 2x first, which starts at 0, goes to 1, goes to 0, goes to negative 1, goes to 0. I'm going to end up at 4 because this is what it tells me. If I have pi over 2, then my period is 4 long. Not 4 pi, but 4. Just the number 4. So my whole cycle ends up in 4. Then, after that, all I simply do is take this one, and everything's going to move to the left by 3. So 1, 2, 3 to the left, 3 to the left, 3 to the left, 3 to the left, and 3 to the left. It's going to look like that. Okay? All right. What's the next one that we have coming our way, Sophia? 23. What is it? Woofed. I thought that was 25. That's 23? There's a lot going on there. All right. So we're going to graph y equals cosine of x first. Okay, I have a pi over 6 involved, so I need to go probably 6. 1, 2, 3, 4, 5, 6 to get to pi over 2. And 6, 1, 2, 3, 4, 5, 6 to get to pi. 1, 2, 3, 4, 5, 6 to get to 3 pi over 2. 1, erase that and redraw it. 1, 2, 3, 4, 5, 6 to get to 2 pi. 1, 2, -1, -2. All right. So I'm going to graph y equals cosine of x first. So it's 1, 0, -1, 0, 1. All right. Then after that, I'm going to make everything twice as skinny. No, twice as tall. Twice as tall. So I'm going to go y equals 2 cosine of x. Because the 2 out in front is a, it does amplitude, so it makes everything twice as tall and twice as short. Then we're going to go y equals 2 cosine of 2x, which makes everything from the orange graph twice as skinny. So 2, 0, 2 stays there. Pi over 2 goes to pi over 4. Pi goes to pi over 2. 3 pi over 2 goes to 3 pi over 4. And 2 pi goes to pi. Then y equals 2 cosine of 2 times x plus pi over 6. What does plus pi over 6 do to the graph? Moves it which way? Left by pi over 6. If I go 12 squares to get to pi, how many squares do I go to get to pi over 6? 2. So it's 2 squares to the left. So from my purple, I go 2 squares to the left. And last but not least, then I go plus 1. So I go up by 1 from the green. So this one involved everything. Making it twice as high. This 2 says twice as high. This 2 says twice as skinny. Pi over 6, we shift to the left, pi over 6. And plus 1, we go up 1. Okay? So we had a stretch up and down, a shrink sideways, a shift sideways, and then a shift up. Okay? That's what we did. Okay, last one. And doesn't that look beautiful? All those pretty colors there. All right, 25. Last one. What is 25? Eli? Folks?
-1 over 2 sine 3x minus pi over 6 minus 1.
Plus 1?
Minus 1.
Minus 1. Like that? Did I write everything right? Okay. So again, pi over 6, and then now there's a 3 involved. I could go 12 like I did last time, or I could just go 3 to get to pi over 2. Because pi over 2 is divisible by 3, and then the pi over 6, I go 6 to get to pi, so then it'd only be 1 square. So for those of you who like squeezing down graphs into smaller areas, I could do it this way. I see the -1/2, which tells me I better go 1, 2. I better leave a square in there for that -1/2 instead of going 1, 2, 3, 4, 5, 6. That's why I usually spread them out a little bit more vertically. All right. So first of all, I'm going to graph y equals sine of x. which is 0, 1, 0, -1, 0. If you don't know this one by now, you've been totally missing the boat. Then I'm going to graph y equals -1/2 sine of x. It's going to be half as tall and to the negative side. Okay. Then the next one. I'm going to graph y equals -1/2 sine of 3x. 3x means it's 3 times skinnier. So I went 3 to get to pi over 2. So I'll just go 1 this time. I went 6. So then I'll go 2. So it just looks like that. Little skinny graph. And then minus pi over 6. How many squares is pi over 6 in this case? 1 square. So I go 1 to the right because minus pi over 6 moves it to the right, 1 square. And then last but not least, I go -1. So I go down by 1. There we are. Okay, that was your assignment. Since so many people are gone, I'll come around and check it next time, so don't lose it, please. Don't lose it. All right. So today we're going to do cosecant and secant.